Hey everyone, I'm Adam Kelly. In this video, I'm going to show you how to create image segmentation masks in Blender. Now, why would you want to create a segmentation mask in Blender? If you're creating a 3D rendered synthetic dataset for training artificial intelligence, then you probably want a segmentation mask. If you don't know what any of that means, then this video isn't going to cover it, but I'll try and provide some resources if you're interested. And just as a reminder of what a segmentation mask is, this is the Open Images dataset, and it has a bunch of different things in it, and all of them have these masks on them. The yellow is the mask, so I'm going to hide that really quick and turn it back on. So essentially what we're going to be doing is creating this mask. Now, in the actual dataset, if you were to download this, they're actually saved as PNG images that are black and white. So the white pixels in the image are the item of interest, and the black pixels are not. They're the background or some other thing. So we're going to try and create those images in Blender with the objects that we have. So I'm using Blender 2.83, and I'm also going to be using Krita 4.28, which this is a relatively new to me. It's not new software, but it's open source. It's really good. Typically I use GIMP for things like this, but Krita just seems to handle different color spaces a little bit better. So I'm going to be using that. You don't necessarily need it, but it might be helpful if you're trying to follow along. So the first thing you'll want to do is go over to the render engine here in this tab right here, the render properties, and change this from Eevee to cycles. Eevee is real-time, cycles is not real-time. It renders a lot quicker in Eevee, but you don't get the benefits that you do with cycles. You have a lot more you can do with it, and this is much more realistic in terms of lighting and everything else. So cycles is the way to go for this. And I have a GPU device, so I'm going to set it to GPU compute so that it'll render a little quicker. Now, in order to do segmentation here, I want to create a scene that has some objects in it that will be rendered. So what I'll do is I'll create a couple more objects here. So you can go up to add, mesh, let's do a UV sphere, and I'm gonna just hit G and Y, and then I can sort of just drag this so that it's sort of in front of the cube here. And then I'm going to add a mesh, and I'll do a cone, and I'll do G and X. And if I render this, I'm going to hit F12, then it should render this, and I should be able to see all three of these objects. Okay, so there's our render. We could make it a lot prettier and put materials on it, but that's not really the point of this particular video, and it'll just take longer and not really teach you anything new. So now that we have this render, what we'd like is to be able to shade each pixel that belongs to each object a distinct color so that we can end up with an image that has, in this case, it'll be 4 different colors. We'll have a black background, and then we're going to do it in grayscale. So it'll be sort of one version of gray, another shade of gray, and another shade of gray. So that's how we're going to distinguish them. So for each one of these objects, the way that we're going to do it for this method, I'm sure there are other methods to do this, but this is the one that seems to work well for me. We're going to select the object, go to this little orange box symbol here. This is the object properties. Go into relations, and we want to change the pass index. So I'm going to set this to 1. Basically, anything that's 0 is going to end up black in our image, and anything that's above 0 is going to be some shade of gray. What we're going to do first is we're going to be saving this as an 8-bit image, which means we have 255 options here, so we can do anywhere between 255. So I'm going to leave this at 1. I'm going to choose the sphere here, and I'll probably set this to something like, I don't know, 27. If you had, realistically, you'd probably just increment it by 1, have this be 1, 2, and 3, but for demonstration purposes, I'm just going to do some different values. This pass index here, I'm going to set this one to something higher, it'll show up brighter, so probably maybe like 200. And now that we've got these different pass indexes, when we render it, it's still going to appear exactly the same in this normal render. It doesn't change anything there, but this gives us some new abilities with what we can do here. We're going to go to let me see, I always forget which tab it's in. I think it's View Layer Properties, and then turn on this Object Index one. And what that's going to do is give us access to which pass index each of these is in our render. We get to that by going to the Compositing tab, and then you can click Use Nodes. So what we see here, I'm going to give myself a little more room here. We have a render layers and a composite. What this is doing is, this is the render, the image that you saw, and this is the composite. The composite is what you saw when it was rendered, that finished image. And right now it's just showing the image. That's what's hooked up there. This index OB, that is those pass indices there. So if I go back here to the passes, if I turn this off, you'll notice that index OB goes away. So you need that there in order to have access to this. So we're going to add a file output node, and you can go up to Add, Output, File Output, and place this somewhere down here. And you can actually hook up the image here, and probably want to give it a path. I'm going to give it tutorial here. So TMP/tutorial, this will actually go in the C drive. So C TMP/tutorial, and the image. So if I were to render this right now, it would just render the image to that folder. If I add another output to this though, then I can get some additional information. So if you click on File Output, and you go to the Item tab here, and expand Properties, what we'll see here is some of the, well, just one thing is the same. So it's this TMP/tutorial is the same here. If you edit it in one place, it updates the other. It tells you what the file format is that it's going to save, the color, and while this may be a little misleading, it's not BW, RGB, RGB. It's actually RGBA, and for some reason it's cut off. They have room for it, so I'm not sure why they did that, but you can hover over them and see what the different ones are. So we don't want to use black and white for our image, but we will want to use black and white for our segmentation. So let's add an input here, and we're going to call this segmentation. And now we've got this new pin here that we can hook something up to. Now we could just hook this up directly, but that wouldn't work very well because our values are grayscale, and they need to be somewhere between 0 and 1. So if we put this here, then we would end up having all of our values be pure white, which isn't really what we want. So I did forget one thing before we move on to that. Let's change this segmentation node. We're going to uncheck this format and change this to black and white. And we're going to leave the color depth at 8 for now. So this is 8-bit color. So we have somewhere between 0 and 255. Those are the different colors that can be output to this image. So next, let's make a little room here, and we're going to add a new node. So I'm going to add, and we want a converter math. And if we put this here, make sure you don't accidentally drop it on top of this, because it'll actually put itself in between. So I'm going to Control Z to undo that. We want to feed in our index OB to this. So this is our object index. We want to divide this. So we change this to divide, and we want to divide it by 255. So what that will do is it will take all the numbers that are the pass indexes, divide them by 255 so that it gives us a number between 0 and 1 that represents our grayscale value. And then we can pass this into here, and it will be able to render out these gray, different shades of gray. Now, you might be wondering why we don't want to use color here. It seems like color is much more visual, looks a lot better. I'll agree with you, but the reason why is actually Blender does not have a great way to handle outputting color images that aren't supposed to be sort of color adjusted. There's this this topic, I'm blanking on what it's called. I think color management, And it's something that basically, if you put pure red into this image, it will not come out as pure red, like an RGB value of 25500. It will show up as like 20600. And that's annoying. It doesn't work well for our purposes, but if we turn that off, then it'll mess with the actual render image itself and it won't look very good. This is kind of a way around that, is to use this grayscale and just feed in a number. So once we have this hooked up, then we should be able to render it and see the output. So I'm going to hit F12 and render this. And you'll notice it looks exactly the same. And that, I can close this now. That is because this is what's showing. But if I go to the folder, that C:/TMP/tutorial, which I already had open here, you'll see that I've got this new image. If I just double click it to open it, you'll see I have the sphere and the cone show up correctly, but that box seems to be missing. Well, it's not actually missing. It is just too dark for us to really tell the difference between black and one value above black. So that's where Krita comes in. If we open this with, let's see, I'm going to open this. Of course, it's not in my list. Let's see, Krita. Then we can click on this, and I'm going to move this aside. I'm going to click on this and show you, if I hover right here, this is where the cube would be. It gives me a gray value of 1. Whereas if I hover over the sphere, it's 27, and the cone is 200. So these are all the values that we set. These were these pass indexes that we set back in here. So our pass index, just as a reminder, was 200, 1, and 27. So that's pretty cool. I was a little frustrated that I couldn't get the colors working. And part of the reason I was frustrated was because I thought, well, what if I need to have more than 255? Because I personally, I can't imagine a scenario where I would have 256 different objects in a scene right now for my current projects, but it seems completely possible that you would have more than 255 sometime over the course of an entire project. If you're rendering out maybe a drive through a simulated, environment, you might have that many different objects in that thing, and you don't want to change them on the fly just to render things. So I did find a good workaround for this, and that is to change the file output from the segmentation one from 8 to 16. And what that does is it changes it from an 8-bit image to a 16-bit image, and 16 bits is actually 65,536 different values instead of just 255. So that's a huge difference. So what we can do once we have this 16 is we can actually take this value, instead of dividing by 255, we can do basically let me see if I can actually type this in. Usually you can do this kind of math inside of Blender. So 2 to the 16th minus 1. Oh, that didn't work. All right, well, it's the number, that math is actually 65535. So we can divide it, and now we've got up to 65,000 different options we can choose from. So if I go in here, and I'll leave this one the same, but let me just change this one to like 1, 2, 3, 4, 5, and I'll change this one to 5, 6, 7, 8, 9. So this one is, much higher pass index. If this were an 8-bit image, it wouldn't work at all. But if I render this, it doesn't render any slower having this many different passes. I can then open this image, and you'll notice that the black is still kind of missing. But if I open this with Krita, let's see, did that open? It's asking me what color I want. Okay, so now I can do this same thing and kind of hover this over to the side. And if I go right here, it's a value of 1. If I go right here, it's a value of 1, 2, 3, 4, 5. And right here, it's a value of 32767. So you've got lots of options with this. As for how you could split these up, that's for another tutorial, I would say. I personally would probably use Python and use NumPy or scikit-image to parse these and split them up and either turn them into Cocoa annotations or the Open Images format, which is basically just take this image and split it into a bunch of black and white separate individual images. That's kind of where you would take this from here. There is the possibility that you're interested in outputting just a select few different masks. Maybe you're only ever focusing on, 2 different objects at a time. So you'd rather that Blender just did the work. So let's take a quick look at how we would do that. So instead of dividing this index object, we actually want to mask it based on what index it is. So let's ignore our cube for now, and we'll use the sphere and the cone. And those 2 pass indexes. This one was, did I change it? 5, 6, 7, 8, 9. Weird. Okay, so I just realized there is a limit to how high passes can go. All right, so you are limited to some degree. I guess you can't go all the way up, but that's still, that's a pretty high number. So I'm just going to make this 10,000, and I'll make this one 20,000. And we'll go back into compositing. And what we want to do is, instead of just outputting 1 segmentation image, we'll output 2 segmentation images. And you could have as many of these as you wanted in theory. I imagine there's some limit to how many different outputs you can add, but I'm sure you can add at least, 20 of them. So let me just disconnect this so that I don't have to completely get rid of it here. But we will mask this index. So we need to go to add input. No, not input. Is it converter? Yes. ID mask. This is what we want. So we're going to pass in the index here, and we want to say that we want that 10,000. That was one of them. And we'll pass that into this first one. And I'm going to duplicate this with the Shift D. And I'll just pass this in here. And the other index I did was 20,000, right? Just double check. Sorry about that. 10,000, 20,000. And then I'll just do this one. This one's 1. Whoops. Shift D. Let's do another one down here. I'll just set this to 1. And I'll pass this in here. And then we would pass this in here, and then I would add one more. Segmentation 3. And pass this one in here. Now, the last thing you need to do with this is just make sure that you, I'm going to change this back to 8. Am I? Yeah, I'm going to change this back to 8 because it's just going to be basically a black and white image at this point. It's masking anything that has this index as being white, anything that's background as being black. So an 8-bit image is perfectly fine. I'm going to set this one to black and white as well, and this one to black and white. And then if I hit F12 to render, now going to here, you can see that I've got these 3 separate images that basically separate the different components here. And it's kind of hard to tell here, but if let me see if I can view actual size. Okay, it's kind of smoothing it on me. So maybe if I open it here in Krita and then zoom in, this is actually a perfectly segmented image. It doesn't have any anti-aliasing or smoothing on it. That is actually desired. You want to know exactly which pixels are the object and which are not. So that is ideal here. We do have some that's happening here. I think the Photos app is just trying to be smart and do some anti-aliasing for us. But in reality, the image itself is correct and it is the exact pixels. So that kind of wraps up this particular method for creating image segmentations. There are some other ways. I think you can use crypto mats, and I've seen ways that are just pure scripting. So, you know, there's other options out there, but this one worked pretty well for my purposes when I was doing some exploring. Hopefully it was helpful to you. Please let me know if you thought this was helpful, and if you want more material like this, that's good news, because I'm planning on creating some more videos and tutorials for this. As always, make sure to check out our social media, and we'll keep you updated on the latest stuff that we're working on. Thanks so much.